Okay, so in this video, we're going to talk about volume using the disk method, except all of my examples are going to go around a different axis from the x-axis to the y-axis. So this is an example video. I showed kind of the basic idea behind this in my lesson video, and then these are a few more examples to go with that idea. So we're going to find the volumes generated by revolving the bounded region around the given axis. So let's start with this one, and this is what I mean by a different axis. So I'm going to have y equals 4x and x equals 1, and I want to revolve that about x equals 1. So you've really got to have the drawing here to help you with this. So if we get this party started, so here is my y equals 4x, and okay, so that's one curve, right? I still need the x equals 1. So I've got this line here, and so here is the solid that we are talking about. And so now keep in mind, we were told to revolve this about x equals 1. So we're revolving it about this line. So I think it's extremely helpful to have a sketch of the solid here. So you just want to get in the habit of that so that you're used to drawing them and then you can reference them as needed. So here's the solid, okay? So I've kept that green line here just so you can see how it's revolving. All right, so there's actually a few things about this problem that we have to unpack because I've revolved this about x equals 1, and revolving it about that line, it kind of feels like when we revolve around the y-axis, right? Except now I've just revolved around x equals 1. And that's important because when we revolve things around the y-axis, what that means is that when I integrate, I want to integrate with respect to y. And so if you notice, this function is what I'd call in terms of x. It's y equals and then a function with x's. So the thing about this is that we need to have this function in terms of y. And that's not like a huge deal, right? So all I have to do is I just have to solve the function for x. So all I really have to do is divide by 4. So this function, y equals 4x, can also be rewritten, right, 1 over 4y. Okay, so up next. Now we have to figure out what is the radius. And this isn't as simple when we just revolve around an axis. This is actually like you've got to use your noggin a little bit. And I think this is where having the solid in front of you really helps. Because here's, right, so here, like here, this is the radius, right? So I need to find the length of this radius. And so this radius, to find the length, the radius starts here and it goes to over here. Or you could think it starts here and goes to out here. How do we find length in general? Well, normally when we find length, a lot of times we use subtraction to do that. So in this case, I have here's, and we always go from the highest to the lowest, right? So here's my start, here's my end. Okay, so in that case then, this is where I start at 1, and then I subtract. So remember, we've converted this, right? So we're using this form of the function here, not 4x. So this is going to be 1 minus 1/4 y. So make sure that that part makes sense because the orientation of this is really key and I think it's easy to get lost in. So if the curve went the other way, if the curve went around the x-axis, then everything would kind of flip again. But since we're trying to write everything in terms of y, so remember with like these functions, right, we always go from the left minus the right when we're doing stuff in terms of y. So we go from the right minus the left when we're doing stuff in terms of y. So just keeping the orientation. So here's what's on the right, here's what's on the left. So 1 minus 1/4 y. Okay, that being said, we've really got everything that we need now. The last thing that I need to know are just what are these points of intersection. So 0, 0, and 1, 4 are those points of intersection. I can figure that out pretty easily. And now I can finally plug everything in. So my radius is represented by this function here. So the radius squared is going to be 1 minus 1/4 y squared. And then I'm going from here to here. So we're integrating everything with respect to y. So I'm looking at all the y coordinates. So I start here at 0, 0, and then I go up here to 4. Okay, so now, there you go. There's your integral. Now, you know, I could say there's just your integral, right? There's still a lot of work involved with this. So now we have to square everything, and I'll just show you the work. I would actually recommend that you try to finish this integral on your own and then watch the work and just check line by line. That's my suggestion. Okay, so here is me foiling everything out. And so when I collect my like terms, so here's what I want to integrate, right? And okay, so now if I integrate, so I'm left with this pi times y minus 1 over 4y squared plus 1 over 48y to the third, and then I just need to plug in my limits of integration. So I've got the work there for you. If you want to check your work against mine, you can always pause the video, but that's the integration part of this. Okay, and I have one more example of this. So I've got y equals square root of x, y equals 2, x equals 0, and now we want to rotate around or about y equals 2. I strongly, strongly, strongly recommend that you try to sketch this out and try this one totally on your own. I will walk you through some of the steps. So the first thing is to get the right sketch. So I would pause and get the right sketch and then hit play. Okay, so there's my y equals square root of x. And okay, so here is where x equals 0 right here. And then, and we had, sorry, and also y equals 2. So the region that we're talking about is this little region in here. And I'm rotating this about y equals 2. All right, so what does the rotation look like? It looks like kind of this funky looking cone thing where y equals 2 is kind of coming through the center of it, right? Okay, so now we're going to do that same exercise. So in this case, it feels like I'm kind of doing something similar to rotating around the x-axis. So with that in mind, I can use this function, right? And so now the tricky part is figuring out what is the radius. And I think that if you are trying to master this, I want you to kind of look at your two sketches and see if you can figure out the radius on your own. It's better to try something that you thought was right and then learn from that mistake than to just be shown how to do it correctly, because then you don't retain anything. So I strongly recommend pause video, hit play. All right, so here is the radius that I'm trying to find out. And so now since we're going this direction, so I'm going top to bottom, now I'm just going to take the top function minus the bottom function to get to that length. So that's 2 minus the square root of x. So that is my radius, okay? The other thing I need to know are just my points of intersection on this. So there we go, bada bing, bada boom. And okay, so now this is going from 0 to 4, pi 2 minus square root of x squared. And so now that's what we've got to figure out. So, okay, I've got all of this. And again, I would just suggest then just to get practice with integration and making sure that you're being accurate, try it on your own, just see if you get it right, and then hit play when you think you've got it. So there is my function when I multiply it all out together. And then there's me collecting my like terms. And so then I can just integrate this function as you see here, and I can go ahead and plug everything in. And so feel free to pause the video if you just want to check your steps against mine. Hopefully you tried this on your own. And so hopefully that gives you a little bit of a better sense of how to do these types of problems. So if you found that helpful, please consider hitting the like button or the subscribe button, and I will catch you guys in another video. Thanks for watching.